This video is to help solve the problem from section 2.3 that is about flying from an airport and talking about Mount Rainier. So it says you're flying from Joint Base Lewis-McChord, JBLM, to an undisclosed location 52 kilometers south and 114 kilometers east. Mount Rainier is located approximately 56 kilometers east and 40 kilometers south of JBLM. If you are flying at a constant speed of 800 kilometers per hour, how long after you depart JBLM will you be the closest to Mount Rainier? So what I like to do first is draw the situation with an XY plane. So here is the point 0, 0. So I'm going to be working a little bit backwards for this. I'm not going to be heading downward as the direction. I'm going to be placing my airport however far north it would need to be from 0, 0. And again, I'm going to put my directions north, south, west, and east over here. So if I'm flying to an undisclosed location that's 52 kilometers south, then if I say that 0, 0 is 52 kilometers south of something, then that something would be up here at the point 0, 52, right? And we're going to call that JBLM. So the place where I'm flying to is 52 kilometers south of that, but also 114 kilometers east. So then I have to mark another point over here that would be at the point 114, 0, right? So that way, if I traveled south 52 and east 114, I would land at my destination. Okay, so I'm going to draw the pathway of this airplane just kind of with a dotted line. And you can draw the airplane in just to help yourself remember that's what we're looking at. So there's my airplane. Okay, and then it says that Mount Rainier is located 56 kilometers east. So remember, east is horizontal. So I'm just going to mark a little point here, 56. Whoops. 56 there. So 56 kilometers east and 40 kilometers south. So where would I be if I went 40 kilometers south of this original point here? So I would be down here, right? And 52 minus 40 is 12. So this point right here would be at 12, okay? So if I kind of figure out where these two points intersect, it would be about right here. So I'm going to call that the tip of Mount Rainier. Okay, I'm just going to draw my mountain there. So that tip of Mount Rainier would be at the point 56, 12. Okay, that's according to my drawing, how I've drawn it here. The 40 kilometers south is actually 12 on my graph because it's 40 units down from 52. Okay, so if I'm flying at a constant speed of 800 kilometers per hour, so I'm going to write that in here as a note, 800 kilometers per hour, how long after you depart will you be the closest to Mount Rainier? Okay, so we need to figure out a few things before we answer that question. The first thing we need to figure out is what is the equation of this line that the plane is flying on. So if I have the points 0, 52 and 114, 0, I can find the slope of that line by doing the slope formula y2 minus y1 over x2 minus x1. So in this case, that would be 0 minus 52 all over 114 minus 0, or negative 52 over 114. I'm going to go ahead and simplify that. I'm grabbing my calculator here because it always helps to simplify fractions, especially if they're larger. So I just simplified this by dividing the top and bottom by 2. So this is the slope of my line. And the y-intercept, so remember the equation of a line is y equals mx plus b. Okay, we just found m, we now need to know b. But b is already given to us because b is the y-intercept, which is 0, 52. So I can write the equation of this airplane line, which is y equals negative 26 over 57 x plus 52. So that's the equation of the airplane pathway. All right, so now we need to figure out what point along this line is going to be the closest to Mount Rainier. Now the closest distance from Mount Rainier to this line would be a perpendicular line. So if I were to draw a line that passed through Mount Rainier but was perpendicular, so I'm drawing like a little right angle there, perpendicular to the plains pathway, then I would be able to know that that was the point where it was closest. So the first thing I have to do is figure out what is the equation of this perpendicular line. So we need a perpendicular line that passes through the point 56, 12, I almost mixed those up, 56, 12, and has a slope that is perpendicular to the red line. Well, a perpendicular slope is the opposite sign and reciprocal. So the perpendicular slope would be positive 57 over 26. So once I have a slope and a point, I can find the equation of that line. So using y equals mx plus b again, we are going to replace y with 12, m with 57 over 26, and x with 56. So 12 equals 57 over 26 times 56 plus b. And then we need to solve for b. So what I'm going to do is go ahead and multiply that fraction. Multiplying 57 times 56 gives me 3192 over 26 plus b. I'm going to simplify that fraction by dividing the top and bottom by 2. So that gives me 1596 over 13 plus b. And then we would subtract that fraction from both sides of the equation. So subtracting 1596 over 13. Okay, so we have that b is equal to 12 minus 1596 over 13. So over here I'm going to write that down, 12 minus 1596 over 13. Now in order to subtract these two, we need a common denominator. 12 has a denominator of 1, so I'm going to multiply 12 by 13 over 13. So 12 times 13 is 156. So this is 156 over 13 minus 1596 over 13. Now that we have the same denominator, we subtract the numerators and we get negative 1440 over 13. So the final equation of that perpendicular line is y equals, my slope is 57 over 26 times x minus 1440 over 13. Okay, so now that we have the equation of the perpendicular line and we have the equation of the plains pathway, we need to find where those two lines intersect. So we have this line here, and we have, excuse me, we have this line here. We need to find where those two lines intersect, because that will be this point right here, and that will be the point where the plane is closest to Mount Rainier. Okay, I'm going to move my video up there. So let's come over here to the left side and solve. So the way we find out where those two lines intersect is we set them equal to each other. So negative 26 over 57x plus 52 equals 57 over 26x minus 1440 over 13. So we will solve this equation for x. First thing we will do is move the x terms to the same side of the equation. So we're going to add 26 over 57x to both sides. Okay, so then we have 52 equals. Now, when I add these two fractions together, I also need a common denominator. And the common denominator, I'm just going to use 26 times 56. So maybe up here I'll write that down. 26 times, sorry, not 56, 57. 26 times 57. And that equals 1482. So that's going to be my common denominator for these two fractions. So when I'm trying to add 57 over 26 to 26 over 57, I'm going to multiply the first fraction by 57 over 57 and the second fraction by 26 over 26. So 57 times 57 is 3249, and that's going to be over the common denominator, 1482. And then we're going to add 26 times 26, which is 676, over 1482. So now we add the numerator straight across, and we get 3925 over 1482. Now, using my calculator, I'm just going to quickly check to see if that fraction can be simplified, and it cannot be simplified. So I'm going to write it down here. So this is 3925 over 1482x minus 1440 over 13. So now we're still trying to solve for x. We're going to add 1440 over 13 to both sides of the equation. Okay, so now we have another problem where we need to add 52 to a fraction, which means we need a common denominator. So using a different color up here, I'm going to write down 52 over 1 plus 1440 over 13. Well, the common denominator is going to be 13, so I'll multiply the first fraction by 13 over 13. So 52 times 13 is 676. So 676 over 13 plus 1440 over 13 will equal 2116 over 13. Okay, so now I'm going to come back down here. 52 plus 1440 over 13 is going to equal 2116 over 13. So this is now equal to 3925 over 1482x. So the last step we would need to do to solve for x is to multiply both sides by the reciprocal of this fraction. So I'm going to use orange for that. So I'm going to multiply both sides by 1482 over 3925. both sides of the equation. Okay, and that way this side of the equation will divide out. And the other side of the equation, I'm just going to multiply straight across with my calculator, and then I'm going to see if it can be simplified. So 1482 times 2116 is equal to 3135912 over 3925 times 13 is 51025. So I'm going to just use my calculator to see if that fraction can be simplified. And it can a little bit. So this is equal to 241224 over 3925. So this is what x equals. Now, what we have found is the x-coordinate of this green point. So this x-coordinate, I'm going to write it in here, 241224 over 3925, comma, and now we need to find the y-coordinate. So the y-coordinate won't be nearly as difficult since we now know the x-coordinate. What we're going to do is take this x-coordinate and we're going to replace x with it in either the red equation or the orange equation. Either one, doesn't matter. I'll just go with the red equation since it appears first up there. So y is equal to negative 26 over 57. Now replace x with this fraction, 241224 over 3925, and then we add 52 to that. So now my job is to simplify this. So y is equal to, so negative 26 times 241224 is equal to negative 6271824 all over 57 times 3925 is, and I'm going to try to make this bigger. There we go. Alright, so let's go back in there. Give myself some more space here. Alright, so the denominator is 223725, and we're adding 52 to that. So 52, remember, has a denominator of 1, so we do need a common denominator in order to add these two fractions. So I'll multiply by 223725 over 223725. So y is going to equal, this first fraction stays the same, and then the second fraction, 52 times 223725, is 11633,700 over the same denominator. Now we can add the two numerators straight across. So I will do that. And I get 5361876 all over 223725. So again, using my calculator, I'm just going to see if this fraction can be simplified. Divided by, and it can, just a little bit. So this fraction becomes 94068 over 3925. Now, you don't have to simplify fractions, but I just like to so that the numbers don't look so big. So this is 94068 over 3925. So that's the point where those two lines intersect. That is the point that once the plane reaches that point, it will be the closest to Mount Rainier. Now, that is not our answer to the question, but it's getting us closer. So remember, the question says, how long after you depart will you be the closest? So we did find the location where it will be closest, but now we have to figure out how long it will take for the plane to get there. So the first thing we'll do is figure out what is the distance that the plane had to travel to get to that green point. So let's go with purple to find that. So first we have to know the distance formula. So distance between 2 points on a graph is equal to the square root of the difference of the x's squared plus the difference of the y's squared. So in this scenario, we are going to be finding the distance between the point 0, 52 and this green point. Okay, so we are going to take the x-coordinate of the green point, 2, 4, 1, 2, 2, 4, over 3, 9, 2, 5, and we're going to subtract 0 and then square it. Then we're going to add, and then the y-coordinate, 9, 4, 0, 6, 8, over 3, 9, 2, 5, minus 52, and then square that. Okay, so what I'm going to do is actually just type all of this into my calculator, and I'm going to be getting a decimal. Because this is not going to be a rational number, which means it's not going to turn out to be a whole number or even a fraction. So that's why I'm going to be okay with using a decimal. In all of these places before, I kept the fraction form because I wanted it to be very accurate. I did not want to mess up my final calculations. So I'm literally just typing this into my graphing calculator, or you can use a free online calculator for this. Just make sure that you put an extra set of parentheses around your fractions when you do type it in, just to make sure. And then my calculator puts everything underneath the radical, but sometimes you might also need an extra set of parentheses around everything inside the radical. You'll just have to make sure whatever calculator that you're using allows you to get the right answer that I'm about to show you. So I'm going to take 241,224 divided by 3925. I'm not going to put minus 0 because that doesn't change the answer. So we're squaring that, plus, and then we're going to do 94068 divided by 3925 minus 52, close that parenthesis and square it. The whole thing is under square root, so my distance ends up equaling 67.5500739. I wrote down all of the decimals that my calculator gave me. This is actually an approximation. It's not an exact answer, but I tried to get it as accurate as I can. Alright, so we're one step closer to the final answer. This is the distance the plane had to travel to get to that green point. Now we want to know the time it took for it to do that. So then the last formula that we need to know is the formula that looks like this. Distance equals rate times time. Rate in this case is speed, and so the distance, 67.5500739, that's in kilometers because everything on here was in kilometers, is equal to the speed. We were told that the speed was 800 kilometers per hour times the time. So the time is the thing we don't know, and the time is the thing that we need to know in order to answer the question. So what we're going to do is divide both sides of this equation by 800. Okay. So I'm going to type that into my calculator, divide 800, and I get this answer, 0.0844375,924. So again, that's going to be an approximate answer. And remember that the speed was given to us in kilometers per hour. So this answer that I'm getting for t is in hours. So I think that the answer or the question on WAMAP would like for the time to be written in minutes. So that's a pretty easy conversion to do. So we know that there are 60 minutes in 1 hour. So if this is how many hours I have, if I multiply that number of hours by 60, I will get how many minutes. So I'm going to take 0.0844375,924, and I'm going to multiply that by 60. And that gives me 5.066255543 minutes. And then, of course, however it tells us to round that answer, we can certainly do that. Inside WAMAP, you should be able to give more digits of accuracy than what it asks for and still get it marked correctly. But this is why I didn't round anything before now. The first thing I rounded was the distance, but that was after I calculated all of this other stuff and I kept everything else in fraction form, because I really wanted to make sure that this answer right here was as accurate as possible. That's what I wanted. So I hope this helps, and please reach out if you need help with anything else.